chemical changes are when you just change the physical state of the matter. The identity of the substance doesn't change. For example, if I tear paper, that's a physical change. I've changed what it physically looks like, but it's still paper before and after. I haven't done anything. Ice melting. It's still water. It just changes from the solid form to the liquid form. Ice melting is a physical change. Putting sugar in iced tea, it's still sugar, it's still tea. The sugar just happens to be dissolved. That's a physical change. Physical changes are not very exciting. We are going to be talking about chemical changes today. And so the chemical changes are a bit more exciting. Okay, Did great. Okay, change in chemical bonds.
I'm going to give you the notes so you don't have to write them.
Okay.
Okay?
A chemical change is a change in chemical bonds. In this case, the identity of the substance changes. So you've created a new substance. Early in this class, I want you to think about chemical bonds as being like Lego pieces. And so all of these atoms on the periodic table, all of these elements of the periodic table, think of them as Lego blocks. And so you take these atoms and you make something out of your Lego blocks. Let's say you make a Godzilla out of the Lego blocks. So then you're going to take your Godzilla and you're going to rearrange those Lego blocks. And you're going to take Godzilla and you're going to rearrange it and you're going to make a tree and a car. You haven't added any new Lego pieces. You can't throw any extra Lego pieces away. Every piece that you started with is what you ended with. But you took those blocks, those elements, and you've rearranged them to create something new. That's what a chemical change is. The identity of the substances change. For example, iron rusting. If you have iron to start with, and then in the air that iron can rust. Now a chemical change is usually permanent, and so you can't get the iron back after it rusts. It's a permanent change. In egg cooking is also an example of a chemical change. You saw me do that with acid the first day. You can do it with heat, but cooking an egg is a chemical change. The egg actually changes chemical bonds, and you can't undo that. A peach spoiling is another example of a chemical change. Once a peach spoils or rots, you can't get a fresh peach back. A banana ripening, an apple rotting, leaves changing color in the fall. Those are all examples of chemical changes. In the fall, the green chlorophyll that's been in those leaves all along breaks down, leaving behind the other pigments that have been there all along also. So now the reds, which were masked by that chlorophyll, can shine through. That green chlorophyll is broken down in the fall. Now, when you have a chemical change, there is usually evidence that this chemical change took place. Not always, but usually there is evidence that a chemical change has taken place. And it's usually fairly obvious. For example, one sign that a chemical change has taken place is evolution of a gas. So you will see bubbles form. The gas will rise up. You can see the gas being released. This can be oxygen gas being formed. It can be carbon dioxide gas being formed. But a gas will be released. You can see a formation of a new substance. Okay? When iron rusts, you can see the formation of rust. That's a new substance. It's been changing the chemical bonds. Formation of a precipitate. A precipitate, does anybody know what a precipitate is? Not precipitation. That's rain or snow. What's a precipitate? Okay, a precipitate is a solid formed from two liquids. If you mix two liquids together and a solid forms, that's a precipitate. The reason they call that a precipitate is for the same reason they call rain and snow precipitation, because it falls from above. Well, if you have a solid formed in two liquids, that solid is going to settle out and fall down to the bottom, kind of like snow in a snow globe. Precipitation. A color change. If a peach spoils, it turns brown. Bananas turn brown. A color change is a sign of a chemical change. You have to be a little bit careful of this because not all color changes are signs of a chemical change. For example, if you have white frosting and you add red food coloring and you mix them together, you get pink frosting. Is that a sign of a chemical change? Has that frosting changed what it's made of? No. So sometimes a color change is not a sign of a chemical change, but often it is. You can get release or absorption of energy. And this energy can be released as heat, light, or sound. Think fireworks. Energy released as heat, light, or sound. And often there's a temperature change. Either the substances get warmer or they get colder. The hot hands. You guys are familiar with the hot hands, those packs that you use when you go snowboarding or hunting to keep your fingers warm or snowmobiling. That's a chemical change, and that's releasing heat. Those instant ice packs. How many of you have used an instant ice pack when you've had a sports injury a lot of times? Okay? That is a chemical change, and we're actually going to be doing that, using those chemicals in the lab to create an instant ice pack in one of our early labs this year. So a temperature change is a sign of a chemical change. In all of these, new substances are being formed. New chemical bonds are forming. Everybody ready?
No.
Okay. Here is some pictures showing the evidence of a chemical change. You have, when acetic acid, which is in vinegar, and sodium hydrogen carbonate or baking soda are mixed, the solution bubbles and carbon dioxide forms. That gas given off, that's gas being released, that's evidence of a chemical change. If you mix these two clear liquids, sodium sulfide and cadmium nitrate, you get a yellow precipitate. That's a solid that's formed. Aluminum reacts with iron 3 oxide in the clay pot. You get energy being given off as heat and light. Or phenolphthaleins added to ammonia, it will change from colorless to pink. Those are signs of a chemical change. I'm going to, it's not so easy to see it there, I'm going to do some demonstrations of some chemical changes. Then I think it's easier for you to see. First of all, if I take this antacid tablet, and if I break it into pieces, one that's increasing the surface area, but what kind of a change did I just do?
Physical.
That's a physical change, okay? But now, if I add some vinegar, this is not necessarily the most exciting, but what do you see happening? Do you see the bubbles? Okay, that is sign of a what? Chemical change. Now these Lego pieces are changing and you're forming new substances and the gas is being released. That's a new product. And so you can see that that's a chemical change. Bubbles being given off. If I tear paper, what kind of a change is that?
Physical.
Physical. But if I take this, now what kind of change is happening? chemical. So burning the paper, you can see the color change, the heat's being given off. That is a chemical change. I'm going to set this into there for right now. Problem is, the ashes are so light that they'll get picked up. Okay. Now just yes. Okay, here's another one. Formation of a precipitate. This is a clear liquid. I add some of this to the test tube. And then I add this. This is sort of clear. It should be clearer, but I dripped something in there. But if I put that in there, now do you see, first of all, you have a color change, right? There's also a solid. That yellow is a solid in there. And as we let that sit, that will actually settle down to the bottom as a precipitate. It's a solid form from two liquids. So that's evidence that a chemical change is taking place. Energy being released in the form of heat, light, or sound. That is a chemical change. So let's go ahead and see light. Does anybody not do well with flashing strobe light? Anybody have seizures as a result of strobes? Because I know there's people at the school who do it. I just want to make sure. This is just a fireworks strobe light. Okay, and that's a chemical change that's taking place. Okay, energy being given off in the form of light. I can do that here too. In the strobe lights, they actually have magnesium. So I can show you here. This is, let me turn on the lights to show you. This is just a strip of magnesium metal. And so I can light this. Now, you're not going to want to stare at this for long. You'll definitely get spots. Okay, so that is magnesium metal being given, or burning. And that is a chemical change. Energy being given off in the form of light. Okay. Like I said, a chemical change, it can be a color change, it can be a change in temperature, it can be a change in heat, light, or it can be a change in sound. Okay? That is a chemical change. That was one of those firework pops. One of the big ones, the fun ones. But that's a chemical change, and energy is given off in the form of sound. Okay? Here's another one. What if I take this sugar cube? So you better pay attention in this class or you're in trouble. And I take the sugar cube and I go like that. What kind of a change is that?
Physical.
That's a physical change. But if I take this sugar and I add it to some more sugar, I didn't want to have to smash that many sugar cubes. Okay. So now I have sugar and I'm going to add some acid. And this is a different kind of acid than we used yesterday. But if I add some acid to this, now you're going to want to watch this. If you can't see, you're going to want to get out of your seat so you can see it. You'll see a color change here in a minute. Do you see it turning dark brown? Okay, and again, you're going to want to get out of your seat if you can't see it in this view mode. And feel free to get out, and I know I'm blocking, but I have to be here. And it takes just a little bit. And a little bit longer. Okay, there we go. Now, usually it will come straight up. Okay, but that's a chemical change. That just smells like burnt sugar. That one didn't get as high as some of the other ones. I'll show you what first periods looked like. So I'll just clean it up. That's what first periods look like. Okay, if that one kind of spilled over for some reason. And then this was second. But, so that's definitely a chemical change taking place. The heat was given off. That's very, very hot right now. But energy released in the form of heat, light, or a sound, or a color change, or a precipitate. And again, the demonstrations show it a lot better than just looking at those pictures. So that's what we want you to see this year. Okay, chemical reactions. Chemical reaction, as I said, is a rearrangement of those chemical bonds. You are taking those Lego pieces and you are rearranging them. You're hooking them together in different patterns, and that is a chemical change. That's the rearrangement of those chemical bonds. You have the same atoms both before and after the chemical change. You haven't added any new atoms. You haven't taken away any old atoms. You have the exact same both before and after. Campfire keeps on going out. I want to burn this. Okay, now in a chemical reaction, the mass does not change. Again, you have the same Lego pieces before and after. So the mass doesn't change, but the mass might appear to change. So we have to, and we're going to learn about that this year. And if I had, and it didn't work very well, but if I had a pile of ashes, would that weight have the same mass as the paper that I started with? Would a pile of ashes have the same mass as what I started with? Would a pile of wood have the same mass as the ashes left behind after a campfire? Mass doesn't change, but why does it appear to change? It condenses. Good try. Okay? So if you, how many of you have hauled in, 30 logs for a bonfire, and when you're done, you got a pile of ash? Does that have the same mass? Is burning wood a chemical change? I said the mass doesn't change. What happened to that mass? Any ideas? What's that? Hey, if you don't know, we'll figure that out this year. Okay? We're going to do some labs on that, so you'll see that. So ponder that one. Mass does not change. Examples of chemical reactions. If we have iron plus oxygen, that yields iron oxide or rust. And hydrogen plus oxygen can form together to make water. Water is H2Os. So if we take H's, Legos from the periodic table, and O's, Legos from the periodic table, and hook them together, we can make water. Everybody ready? Okay, reactants. Reactants are the parts that you start with in a chemical reaction. So it would be the antacid tablet and the vinegar. Those are the reactants. That's the pieces that you start with. The reactants are the acid and the sugar. Those are the reactants. That's the things that you start the chemical reaction with. The reactants would be my two liquids here. Now, when I taught biology, you guys probably don't need this, but when I taught biology, when I was teaching photosynthesis, I told the kids to think of the reactants as the reactants. Those are the parts that go into the chemical reaction. So for photosynthesis, what goes in is the carbon dioxide and the water. Those are the reactants. Those are the pieces that you start with. The products, that's what you end up with. Here, the gas in this liquid, that's the product for the antacid demonstration. The black carbon snake, that was the product for the sugar and the sulfuric acid. This yellow precipitate, that's the products. Can you see that there's yellow down at the bottom now? Okay, that's solid. If we let it sit longer, all of that solid would fall out of solution. And again, it's like raining in there or snowing. It's a precipitate, a solid formed from two liquids. One way to think of the products are the products. That's what comes out in that photosynthesis reaction. The products are the glucose and the oxygen, the C6H12O6 and the O2. Now, we saw two equations before. These are the same equations. We have iron plus oxygen yields iron oxide. In that equation, what are the reactants?
Iron and oxygen.
Iron and oxygen, that's what you start with. And what's the products? The iron oxide or rust. Very good. And in this equation, what are the reactants? What are the reactants? The hydrogen and oxygen. Very good. And what's the products?
Oh, wait, what?
Water. Very good. Okay, so the reactants are what you start with and the products are what you end up with. Okay, and that is actually the end of our notes. Now, what I'm going to, you can check